Hello. Hi, anyone listening? Yeah, I understand. Whoever decided to have me go after Aaron, thank you. At least Aaron isn't able to send mean tweets about me because he just got his account suspended. So I know that there's one person who will be listening. Anyway, I'm Konstantin, and I came here from Berlin. And I took a very, very smart route to come here. Started off in Berlin. I then went to Doha in Qatar, where I actually spent quite some time. Landed in Saudi Arabia on the way. Then I went to the Philippines. This was supposed to be 18 hours. Turned into 3 days. Took me 5 days to get my bag. Went to San Francisco and took a red eye to Florida. It's a highly recommended way to get from Europe to Florida. So anyway, so my bag got lost, and I'm now facing the situation where my bag has its own Twitter account and it's actually more popular than myself. Let me be the first to welcome you to St. Augustine, the oldest city in America, or at least that's what I heard. So, the 3 things I'm really good at: it's history, geography, and telling people that they are wrong. Oh, and bullets on slides. So I heard this, last year was even on the conference website, and I'm like, as a European, I'm very proud that we're all historic and whatnot. So, oldest city in America was like, what's your definition of oldest? What's your definition of America? So I wanted to figure out, what does it mean, oldest city in America? So I looked it up, came up with a table depending on your definition. It's one scale is your definition of oldest city, the other scale is America. Apparently, so if your definition is the oldest European settlement where there are people living today in the continental US, then it's, however, I'm not sure how to pronounce it, yeah. So, but there's still a definition where St. Augustine is actually the oldest city in America, because this city was uninhabited for almost 10 years, sometime when the British conquered it. Like 300 years ago or something like that. So, if you make that a requirement, then St. Augustine would actually win. Interestingly, also, you notice I didn't know how to pronounce it. I think the one city I have the least problems with is Eastrebug, which is the first European settlement in the Americas. It's actually in Greenland, but apparently that's America. Anyway, don't take me too serious. I'm actually here to talk to you about security, about hackers. So there is this easy way, that all the stories are usually structured when you talk about security, and it's about Bob and Alice. I'm not sure I should be talking about Bob and Alice, though. I mean, you can have amazing stories about Bob and Alice. I love this sketch, actually. Like, but Bob, in a quantum world, how can we be sure? Instead of Bob and Alice, I actually want to talk about real people that I work with. I work at Travis CI. Those are the 4 founders in our company uniform. Yes, that is a onesie. And there's this guy, Josh. So Josh recently started windsurfing. And windsurfing is really hard. There's super dangerous situations. For instance, you might fall off. And the big problem is, this water it's very dangerous there because sharks. It's actually a big, like, we went on the boat and I'm really happy no one fell in the water. Because sharks, there's sharks everywhere here. Like, you go out in the water, you will die. But, so, we talked about sharks yesterday and I thought, like, oh, I'm gonna add that to my talk. So I added the shark slides and then I thought, okay, so how do I make this about websites again? About web applications, about web security. So imagine, if you will, sharks attacking websites. That is way better than any Alice and Bob story. But seems a bit far-fetched. Like, why would a shark attack a website? It's a hard question in IT always. So there is one website that sharks really, really don't like. It's this website that tracks where there are sharks. So right now there are like 3 great whites, or of all the sharks in the world that are tracked, right now there are like 3 great whites outside of Jacksonville. Again, do not go in the water. So as those sharks want to eat us all, they want this website gone. One last advice before I talk about the attacks the sharks actually can perform on our websites. If you wanna avoid sharks and you have to go in the water, there are frequencies that sharks don't like that you can use to get rid of them. So you just sing them out loud while you go in the water. It goes like dun 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 dun. Okay. No, serious. So, web security. Who here thinks of web security when they write applications? Web applications. Okay. So what do you think of? Which attacks? What's common? Guess cross-site scripting. I guess who has heard of cross-site scripting? Yes, yes, yes. Who has not heard of cross-site scripting? I have it in here because it is an element that is used in other attacks. So it's important that you know what we're talking about. What we're talking about is there's user input, it's presented somewhere on the website, and someone just injects some HTML or JavaScript that does something. It's very common. We saw that in Aaron's slides where he actually escaped unsafe strings, and that's what you need to do. You need to sanitize all user input. There are actually other ways. Like, you definitely should do this. But there are also other ways to prevent some cross-site scripting attacks. There is this content security policy header. Have you heard of this? It's very, very, very powerful, where you can say the following content may be loaded from the following domains. So self is the magic, is the same origin. So your own domain. So this one says you may only load JavaScript from your own address and from Google. And there are other things. You can say that for basically anything. You can say that for style sheets, which might seem like, oh, style sheets not really dangerous. But if you can influence what the page looks like, you can actually do a lot of harm too. And one nifty feature is you can actually send it a report URI. I'm not sure if all the browsers implement this, but you can send it a report URI that the browser will contact for violations of this policy. So if anything tries to load a script from a different host, it will post a report to this address. Really great. You should look into it. Okay. Other attacks that you know of. Anyone?
Man in the middle.
What?
Man in the middle.
Man in the middle. Okay. I'm gonna come back to man in the middle later.
Account enumeration.
Okay. So what I was actually going for is cross-site request forgery. That's like the second attack that you usually use for browser-based attacks. This is a very straightforward attack. All you need to do is have a decoy website that you lure someone to go to. And sounds hard, it's actually not. So there's actually even some temptation, and I go into that in a second or in a few minutes. There are reasons that you want people to stay on your website for a while. And the problem with this website is it's old. Like, no one watches Neo and Cat anymore. So you can't really, so the sharks would not set up this website right now because like the joke is quite old. But there's a new website out there that actually has a lot of copycats. Not sure, have you seen this game? It's amazing. I was actually considering doing a talk instead about what the best strategy is to win this game. And so the most amazing thing to me with this game is not just a game, but there is a sheer endless amount of copycats that have variations, like forks of it that do awesome stuff. I personally really like the Fibonacci version. But there's also this great one, the Dodge version. It's a bit hard in the beginning because you need to kind of memorize what the values are, or at least like the order of how do you pronounce it? Doge. The order of doges. What's your order of Doge? And so they abuse a simple fact in how our browsers work. That is, if you send a request to a website where you are logged in, or where you have been before, all requests will include the session cookies, if session cookies are used. All requests, no matter where they're originally triggered from, as long as they are triggered by the same browser session. And now what you can do is, if there is a URL that performs some harmful action or some modifying action or something, you can, for instance, just take that URL and embed it as an image. It will not be displayed, but it will still trigger a request, and the request will still have that cookie. Now, there are easy ways to prevent this. In HTTP, there are those methods or verbs, and they all have different properties, and I have a completely different talk about this, where I talk about all of them and why it's cool that we have all of them. But simply, what you should be aware of is there are those safe HTTP methods. That's get, head, and options. And those safe HTTP methods should never change anything. So you should not have a get request for taking down your shark tracking website. But that only takes you so far, because that website could actually have a hidden form, and it could take that form and submit it via JavaScript, and you don't ever notice because you're playing the game. So what can you do against this? What do web applications do against this? Actually, web apps, frameworks like Rails or libraries like Rect Protection, which is what Sinatra uses, will try to prevent such attacks. And there's a well-established method for that, that is using CSRF tokens. So these are randomly generated tokens. This would be how you would implement it in Sinatra, for instance. So it generates a token if it's not there and stores it in a session. And then if this is a submitted form, it will compare if the form contains a token and if that token is equal to the generated token. So only if the two match, it will let the request through. Of course, we'll have to check that it's not a safe request, because we can't actually block out GET requests, because otherwise no one will be able to visit our website in the first place. If you wonder why this is so strangely arranged with the if here and the unless, then that's because that way it fitted on the slide quite nicely. So that is, in a nutshell, what Rails and Sinatra do for you automatically under the hood. And then when you have a form, it will have a hidden field in there that will have the token, and it's not actually writing it as a cookie, it's actually writing it in the session store, which then will be written as a cookie. So you can compare the two. And this is the standard defense against this. Keep that in mind. We will come back to this. Another very, very basic attack that I've seen happen a lot against old Sinatra versions before rec protection was added is, for instance, a path traversal attack. So one thing people used to do is take a pattern from a Sinatra route and map that to a file name or something they read from disk or a template. So you just match a path and then you use that to present a file. And you'd think that's safe, because so what dangerous things could happen? You could like navigate to a different directory by using slashes and dots and so on, but the pattern would not actually match this, because that's how Sinatra and Rails patterns work. It would not match a slash. So one thing you could do is you could encode a slash. This is actually the URL encoding for // and you could add that in there and then it would match to the name. Sinatra currently does not do that if you have not explicitly enabled this behavior. And people keep opening issues about this, saying, hey, you're actually violating the HTTP specification because that says you should actually match the parts of the path before you unescape these things. And it's like, yeah, okay, but if I do this, then there are plenty of applications out there that just are insecure, because then the sharks will come, output your password file, and access your server. Another nice thing that sharks do, actually not sharks, so sharks have one problem. They're not really good at typing. But maybe they cooperate with someone. But anyway, so I'm not actually sure if I'm going to take this shark story any further. It's getting kind of ridiculous. So another common thing will be clickjacking. That basically, it works like the CSRF attack. So they lure you to a website and then they make you click on something. And that something might be an iframe embedding the other website that's under attack. And it might be sized in a way that you don't recognize it, for instance. Or browsers now have this cool thing where you can make click-through objects that you can actually put in front of other objects. And then when you click on it, the click actually goes to the element behind it. Facebook suffered from this a lot, I think, in the beginning, where people would then share things that they were not intending to share, and other people would click on that and then do the same thing, etc., etc. But there's actually a really easy solution, and again, Sinatra and Rails now do that by default. There is a header called X-frame options, where you can have different modes, where you can say, yes, this page may be embedded in an iframe. Or no, this page may not be embedded at all in an iframe. Or the third version is it may be embedded by the same origin. This is the second time I mentioned the same origin. So let's talk about this. Who has heard of the same origin policy? I want to see more hands up there. Aaron. So this is where you usually hear from this is when it comes to JSON and AJAX requests. So this is this thing where, so the origin is the schema, so is SSL used or not, it's the domain, and it's the port. And basically the same origin policy says resources like a JSON file may only be loaded from if the origin matches. There are ways to disable that with like cross-origin sharing, etc., but by default this should not be possible, so it should be safe to load JSON. Well, turns out that's not 100% true. Does anyone remember VB script? So VB script is this alternative to JavaScript by Microsoft that will eradicate JavaScript because it's way better, because it's based on Visual Basic. So it turns out they had this security issue in all the versions that supported VB script, which is, I think, Internet Explorer up until including number 8 or something. I'm not too sure. But they had the security issue where they simply never fully implemented the same origin policy. So under certain circumstances, a VB script would be able to load some JSON, some XML from a remote server, and there was not much you could do about it. What can you do about it, really? I know one option. You could block Internet Explorer. No, I'm going to discuss a different option in a second. Or well, if people upgrade, but you cannot really rely on your website security being based on people having a recent browser. But so there are even other options to attack a JSON file. So since your JSON is protected by the same origin policy, you might just authenticate it with your session and just serve it, because what harm can be done by serving a JSON file if only your domain can read it? So if you have a session authenticated JSON endpoint that returns an array at top level, there is a way to load it. So imagine, if you will, you take this URL for the JSON and you embed it as a JavaScript in a different website. It works. JSON is a subset of JavaScript. It doesn't really do anything because there's an array at top level that is not written anywhere, but it's loaded. Same origin policy is circumvented. The Doge website can load your JSON. But what's the harm really, except for the browser reading it? Well, if it's an old browser where this problem is not explicitly fixed, the website can abuse how powerful JavaScript is. So did you know that in JavaScript you can override the array constructor? And you can do this before loading the JSON. And then basically, this is one way to do it. This works. I tried it in older versions of Firefox. I have a project down there. So you put this code in your HTML, then after that you embed the JSON that you want to read as JavaScript, as script with a script tag, and then this constructor will get called for the array that's loaded. And basically down here is the code that you need to replace to do whatever. So this version will just write it to the website that you're loading, which obviously is stupid because the person loading the website will notice that there's something fishy going on. What you would actually do is post it to some other endpoint where it's stored, for instance. This does not work in newer browsers, whether it's explicitly disabled, but in older browsers this just works fine. I think you need to change the code a bit in Internet Explorer. I haven't actually tried it because I don't have Internet Explorer. But this is a very, very nifty attack. So how do you fix this? What you do is, if the endpoint is a JSON endpoint or if it's an AJAX request, you simply always require the CSRF token, even if it's a GET request. So it cannot be loaded by a different page because that other page does not actually know that token. Okay, so our sharks are thinking, what can we also do? What else can we do? There's another attack. That's where you leak information over a referrer. So the referrer is this HTTP header that tells you which page someone else came from. It's really handy. It's used by Google Analytics, for instance, to analyze where your traffic is coming from. So all that the attacker needs to do is embed a link that you click on, and then when you click on that link, it will trigger another request where it will include this header. And if the first URL included is secret, then that can be read from the referrer header. And this is not a typo on my part. This is a typo in the HTTP specification. It needs to be 2 R's, but they misspelled that in the beginning, and now it's misspelled everywhere. And you think, okay, so yeah, but this seems stupid. Who today has secrets in the URL, really? Well, actually, OAuth has, for instance. So if you do an OAuth handshake, and then that page goes somewhere else next directly from the OAuth handshake, then you might actually leak OAuth information. You might leak an access token, and then the other page can perform things as you. So there are a few ways to circumvent that. For instance, simply using SSL will circumvent it because browsers will not send the referrer header if you're coming from HTTPS, because the whole thing is encrypted and the browser assumes in the first place that it might be sensitive, etc. Another thing that a lot of websites do is they add a redirect endpoint. So you would not, for any link that you click on, you wouldn't go directly to that link. Instead, you go to some other URL on that website that then has the link you wanted to go to as a parameter. And that obviously gets the secret back here, but it's our website. I call it good.com, so you know like where you're standing. That goes to our website, so they never see it, because then the request to evil.com will only contain this redirect parameter. Yeah, so the reply looks like this. The location is here. This seems good. So what could be the harm in doing this? Well, actually, there's another attack that is opened up by this behavior. It's a header injection. So if you look at HTTP, all these headers and the body itself are separated by new lines. So if you could inject new lines, then you could inject new headers. The problem is you can't actually inject new lines easily because the server knows, there's a new lines and a new header starts here, so I need to escape them somehow or turn this into, Rec would actually turn it into 2 header entries and then use the key again, etc. But one thing you could inject, which seems safe, it violates the HTTP specification, but it seems safe, is what's it called, a line feed. So this character is actually not allowed here. You know, if you use Windows, it's /r/n is actually the new line instead of just /n. But nothing really happens, except if you're in Chrome. Who here is using Chrome? Okay, Safari, Firefox, something else, E-links. Okay, so okay. So Chrome actually treats it as a new line. So if you manage to set a header value, you can inject your own header. Moreover, you cannot just inject a header. You can, depending on which headers came before it, even inject a body by doing a double new line and then hiding the rest of the page. And boom, you have a cross-site scripting attack, because that body could then do whatever it wanted to. So this can happen whenever the user actually has the ability to influence the value of headers. Like whenever there's user input that will go straight to headers, this attack is possible. One of such things is a redirect endpoint. This is the URI encoding for the /r. So if you have a request like that, and the user input is not properly escaped, then you can end up with something like this, and the attacker can, for instance, set a cookie. This is a very nasty attack, and yeah. So what you need to do is whenever you put user input in header values, you need to escape it. So Rails, for instance, escapes it for the location header, but for nothing else besides the location header. So if the website, if the user just repeats something, if the developer behind the website is not aware of this and just repeats something in some other header that is not the location header, then this will be injected right away even in a Rails application today. Let's talk a bit more for a second about cookies. Cookies are really dangerous. They're used for authentication. But so if someone, so that enables the cross-site request forgery attack. But you don't actually need that if you can get a hold of the cookie. There comes the man-in-the-middle attack. You would need to read the traffic, then you can capture the cookie, and then you can use it to send your request yourself. You might say, oh, it's really hard to capture a cookie because you actually need to be in the middle between two. Well, if people are on an open Wi-Fi, which I know most people in this room here probably are right now because it's not encrypted, the hotel Wi-Fi, then you can just see all the traffic flying by. A few years back, someone came out with a really, really nice browser plugin that you just install in Firefox, and then it just captures all the traffic flying by, and it knows some common websites, and if it sees the cookie for, say, Facebook or Twitter, then it gives you all the versions it saw, and then you can click on it, and then you're logged in as this person. This attack works marvelous. I've tried it myself. It's very, very good if you want to have inappropriate tweets sent by your friends. Turns out people get very upset if you do this. Works. And so what could you do? You could encrypt the cookie, for instance, or sign the cookie. You could try stuff like that, which your web framework will do, but it doesn't actually matter because the attacker does not need to understand what the cookie actually means. It does not need to understand what is actually stored in the session. It just needs to get a hold of the cookie and reuse it. So the big question is, how do you prevent the attacker from getting hold of the cookie? There's a very, very simple, very common solution that Facebook, for instance, uses, that you all should be using: SSL. You use SSL and your website is safe. Nothing can harm it. Well, there are a few attacks. There's this one called, they all have the perfect names. First one is called Beast. Beast stands for Browser Exploit Against SSL TLS. Okay, that makes sense. That's actually a really nice name. And what it does, it allows you to decrypt SSL by injecting plain text, for instance, JavaScript. That is a vulnerability that has been known for years. And that is why TLS 1.1 fixed this in 2006. But there was no proof of concept until 2011, which means no one upgraded, because why should you upgrade? But if you upgrade, this is fixed. So why are we even talking about it? Well, for instance, Heroku is still running on TLS 1.0. Okay, but this is one attack, so we can protect against that. But there's crime. Crime stands for Compression Ratio Info Leak Made Easy. Okay, I feel like this name is already getting a bit more ridiculous than the first one, but still it kind of makes sense, and that's based on the fact that SSL has built-in compression. And this is really important, because otherwise if you enable SSL, your traffic would go through the roof. The request and the response are both compressed by usually with some dictionary-based compression. So if a website can now trigger requests and change the request type, it can actually, and at the same time look at how good the compression is, it can figure out your cookie value. How does this work? Well, imagine you're playing Doge 2048. In the background, it keeps triggering requests. It tries to figure out the cookie, which is user equals Bob, and then it just goes through possible values. And so if this matches, it compresses better. Not only if that matches, even if it doesn't fully match, but matches better, then the compression of the request will be better because the dictionary compression will figure this out. And so this seems at first like a brute force, but it's not actually, because you can improve character by character and become your result, the compression gets better and better. and you construct the cookie value. And you don't actually need to know what's in the cookie. Works really well, takes a few minutes, and you have the value. New browsers have a protection against that built in, where they simply don't compress the cookie header. So everyone thought this is solved. There's actually some code in the frameworks to protect against this too, etc., etc. But then last year came a variation of the attack that I have not seen a framework out there that protects you against this variation right now. It's called breach. Browser reconnaissance and exfiltration via adaptive compression of hypertext. It's like if you try to figure out what this attack is about simply from the title, it's like I have no idea what I'm doing. I realize Aaron just used this slide. So in honor of Aaron using that slide, I put up an Aaron slide. I promise you, conceptually, this attack is easier to understand than its name. It's still a hard attack to perform because you need a lot of preconditions, but understanding this attack is actually easy. And I can't switch to the next slide because everyone's taking a picture. No, do it. You can't tweet it anyway. I'm not even entirely sure where I got this picture from, but I have it in my picture directory. I have like a few pictures called Aaron 1, Aaron 2, Aaron 3.
Stand closer. I want you in the photo.
You want me in the photo? Yeah. My time is running up.
Thank you.
Okay, so breach. Breach works like crime, but crime actually attacks the request compression. Breach attacks the response compression. And it does not attack the cookie. Instead, it attacks the CSRF token. Because once you have the CSRF token, you can run a CSRF attack again from some website you get people to visit. How it does that is you need to find an endpoint that always returns the same result, except for a string that you can insert that gets repeated in the body. A very good example for this is a search page that says no result found for whatever you paste in back here. And then the closer this value gets to the CSRF token, the better the response will be compressed. So you do the same thing again. It basically works like a timing attack without all the downsides of a timing attack. And then you have the CSRF token, and then you can, again, submit a hidden form with that CSRF token, and boom. Now we know about all these attacks, so we can write secure websites. Do you think this has been going good so far? I feel like the next attack is just around the corner, but let's get more philosophical. The big question is, can we trust requests? And this also boils down to, can we trust the browser? I think generally, yes, there are probably very, very smart people behind browsers. Sometimes they have very stupid worldviews, but in general, they probably know what they're writing code-wise. But this goes further. Have you ever thought about browser plugins? Can we trust browser plugins? Browser plugins are basically voluntarily exposing yourself to CSRF, to cross-site scripting attacks. So take this browser plugin I was using for a while. It's called Cloud2But Plus. It's actually quite good. So you install it, and whenever you go to a website and the website says cloud, it replaces it with but. So I read a review of Cloud Atlas and became but Atlas. Even better, it replaces the cloud with my butt. So get ready for the cloud becomes get ready for my butt. It was super entertaining until something went wrong and something was using Cloudflare, and I got a redirect to Buttflare, which turns out is a porn website, while I was trying to give a presentation. So the big problem here is I have not reviewed the code of this, and how browser plugins work today is they just load some JavaScript in your website, and that can do anything. That circumvents same origin, that circumvents your content security policy. That, for all I know, this was monitoring everything I did and sending it out to the sharks. So, what do we do? Not use browser plugins? And in all of this, we haven't even talked about social engineering. It's when people just pretend, hi, I want to do a security inspection. Or, so we're getting a verified Twitter account. So you give them a phone number, and so I just played out in my mind. Imagine someone now calling you saying, hey, I'm from Twitter, we need to verify that you are you. Can you give me your Twitter password? That's social engineering. And it might not work on you because you're an engineer, but imagine that happening to like some media person somewhere. And another thing we have not talked about is actually attacks based on your server software, not on the protocol HTTP. So any of you parse YAML? It has been mentioned before. We had this really big vulnerability where someone could, like I constructed a payload. We had Travis CI, we parsed YAML files. Every repository that is on Travis CI has a travis.yaml. And I came up with this payload that would allow you to just establish a connection to our production database from a repository tested on Travis. Luckily, no one came up with this because everyone was worried about Ruby gems being hacked at the time. Do you keep all this in mind? And as I said, I think the next attack is just around the corner. And these are questions, or the question here is actually, so what do we do? And these are questions I don't really have an answer for. But I hope you enjoyed my talk, and thank you.